Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 2131. It's called Longest Palindrome by Concatenating two-letter words. So you're basically given this string array words and you want to find the longest palindrome. Recall that palindrome means the same forward as backwards that you can create. And so let's just look at the examples here. So basically here, notice that these two are the inverse, which is going to be really important. And then you can pop a letter in the middle of odd length that is the same forwards as backwards. So that's kind of the idea. And if we look at the other examples, it kind of verifies that. So these are inverses, and then this is just the same letter. The entire word is of the same letter. Okay, cool. So let's also just look at this example, which means this is the same length, this is the same length, this is the same length. You can only pick one of them, so it's going to be of length 2. And looking back at this example, it looks like this is actually what it is. There's no TT, so it's just these two and then these two. Cool. So let's try to go ahead and create this sequence. And the first thing I'm going to do is go ahead and sort the input. And we're going to want an answer that we're going to return. And let's go ahead and actually make two dictionaries. So let's call this total. And they're both going to be starting with the same thing. So if we print total, you're just going to get how many characters we have. And what we're going to do is, since we've already sorted words, we're going to look for the in reverse in the right hand side of the array, right? And then we're just going to sort of knock the current one off and then see if there's still the inverse, and then knock this one off and see if there's the inverse on the right side, because we're just going to be building it from left to right. And the idea is at the end, if the second dictionary is still having words, because the point of the second dictionary is that instead of, we're trying to figure out whether we need to do this at the end, whether there is a letter with just one, and we can't do that with the original dictionary because by the end it's always going to be cleared. So let me just show you the idea that I came up with here. So for I in range length words, let's call this cur is words of I. So first of all, if the inverse, let's just call this reverse, is -1. So if R is in total, so we're actually just going to decrement this before we do anything. And obviously if the frequency is 0, then it doesn't exist. So we're going to delete that key value pair entirely. And then let's go ahead and print words of I and R. And obviously this means that it's going to be a fit, and we're just going to decrement R as well, because it says here you can only select each element at most once, right? So let's go ahead and print this. Okay, so words of I. Let's call this perhaps some stuff that needs to be done. That's odd. Maybe we deleted it. Why would it not be? Why would it be out of range? Let's see. That is odd. Very, very weird. Let's call this words of I. Okay. So That is weird. Let's go ahead and print words. So why are we modifying words? Delete total of rights. Oh. Delete total words of I. Okay. Anyways, yeah. Small typo there. That's fine. So the idea is we're just going to keep adding the current and the reverse, right? And then the idea is in the use dictionary, because we're not going to do this because we're just deleting this as we go, which is not what we want, because we want to figure out at the end if there's a leftover element that's not paired up with any other one. So used of R minus equal to 1 if used of R is equal to 0. So we're just going to delete all the matching pairs instead of all the elements in this used dictionary, right? Okay, so at the end, and we're obviously going to add length of words of I and do it twice because the length of the reverse is the same, and we found a matching pair that we're not going to use again. So then at the end, we can go through used. And if this is just going to be one character, then we can add the length of U and break it because we're not going to want anything else, right? So let's print U. And just so you guys can see. And then at the end, we're just going to return answer, right? Okay, so let's see. Perhaps we need less than or equal to. Okay, so let's print answer. Oh, and by the way, if we're ever over the limit because we can't pick, there's only so many characters, right? So let's call this size. Size plus equals to length of W. So if ever answer is bigger than or equal to size, then we just break this, right? Okay. So, and words of I is in tote, I guess you can say that. Or no, because we have already done that there. We've already deleted it. Let's print used at the end. This is already over, so let's return the minimum of answer and size. Okay, and let's say words of I is not in scene because we're only going to use one word once. Scene.add words of I. Okay, so getting closer here. Okay, so if it's 0, we're going to delete it, and let's not do this there. So notice here that, let's actually go ahead and print totes of R. Because we have two A's, so perhaps, and we've already sorted words. So 4, 8, 12, 16. Why is it just one more at the end? Perhaps it's this times however many we have, right? Because the number of pairs or not. Or maybe there's not a duplicate. I guess each element can only be selected once. Okay, so this is weird because less than or equal to 0. Okay, so it looks like we're decrementing and actually going to -1, which we don't want. So that's why I did that there. Okay, let's run this again and submit it. Okay, and there you go. Passes all test cases. Yeah, so again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for this video, and thank you for watching.